I think this is all of your, I mean, at least some of your favorite game, Sudoku. Most of the time you try to play this game. So the here this problem is like that. In the Sudoku problem, there is a 4 cos. Just I'm taking some pen for laser. Okay, so this is a square of 4 boxes. Okay, so the a number 1 2 3 4 goes in every cell, so we can write 1 2 3 4 here, 1 2 3 4 here, 1 2 3 4 here, 1 2 3 4 here. So and every row column mini grid must contain the number 1 to 4. So this is the problem, so you need to solve this problem. Okay, so I think I have given this problem to you. I think you already start thinking how to solve this Sudoku. There should be some kind of steps you need to follow, you need to think. I need to start from one mini grid to other mini grid. So okay, I'm just trying to move and trying to solve this by step by step. So okay, let's tackle mid grid, mini grid by mini grid in every row. Let's start with the top left grid. This is the top left grid. 3 is written here, and 2 is there. So it's not 2 is possible here. This is 1. 1 is also not possible here. Okay, this is 1 is also not possible here. So this way we need to think. Okay, so what are the steps? Okay, let's now try to each number starting with 1. Mini grid doesn't have 1, and should be one of the empty squares. So should be empty square, should be 1 should be there. So in the second column, blue, in the blue screen, 1 is the last row. This is the last row, so blue, so 1 is not possible here in this column. Okay, so maybe we can this is the right, if we can put 1, then it's possible. So therefore the only possible place of the 1 in the top left. Okay, there's a grid in red. Okay, similarly we try to find out the I mean number 2. So in the number 2, here already number 2 is there, so number 2 is not possible. So the only possible area is this area. Okay, so similarly, we can think for this is number 4. So 1 2 3 4 we solve. Similarly, we try to solve the other mini grid. Okay, so this way we will move forward one by one grid we will take and try to go for I mean combination kind of thing. 1 2 3 4 we will check. There are 4 number. Okay, so so here also it's a clearly there is the only place for 1. This is the only place. So you cannot write 1 here, you cannot write 1 here, because already 1 is there in this mini grid. So only place to write 1 is here. Okay, and can you see can anybody tell me what is the position of 3 and 4? Can I write 3 here or 3 here? Can anybody tell me?
Yes, sir. Below to 2.
Yes, below to the 2. Why?
No, below to 1. Below to 1.
Okay, why?
Because we can't put 4 above to 4.
Right, we can't put here the 4 because already 4 is there. So so this I mean this blue section we can write only 3. Okay, so similarly, so write 3. Both the 3 is possible, but the 4 is actually there, so it should not be there. The 4 will be there and 3 is there. Okay, so you are right. So this way we will think that which I mean square will take the each and every. So can you tell me, can anybody tell me the what is the this block, this area? 1 2. Can we write 2 here? No, it's not possible. Can we write 2 here? Okay, it may be possible. Can we write 2 here? Okay, it is also possible. 3, 3, it is not possible to write 3 here. Okay, because 3 is already here. Okay, so can we write 3? Okay, so this may be the right position of the 3 only, because 3 is not possible this area. Okay, so maybe that we can write 3 here. Okay, so this way we can think 2 is both the position is 2 is possible. But this is the only section where square where we write 3. After that, this is the only location where we write to 4, because 4 is not possible because 4 is here. Okay, so this is not the right position of the 4, so this is the only square where we need to write 4. Okay, so if this is 4, then we can write 2 here. Okay, so this way we can also think. Can anybody help me to figure out this section one where we write 1?
Yes, sir.
Yeah, please go
Yes.
ahead.
In first column we put here 1.
Okay, here.
Yes, sir.
Okay, okay, 1 here.
2,
Okay, 2,
and
3,
this 3.
3. Okay, let me check. Okay, so 1, right, 2 and 3. So each and every time when we try to solve the Sudoku problem is like it's a simple one, like a 1 to 4, but here also some steps are important. So each and every time we try to think, and step by step manner we try to resolve one grid by another grid. And some confusions are there sometimes. Maybe the twos can take place from the two any areas, but after thinking the next step, then only you can go back, come back again and again, you maybe resolve those things. So this is another problem. Okay, so let's count our chocolates. How many chocolates we have here? Only one. Okay, so how many ice creams we have? Only one. Okay, so but if we can mix chocolate and ice cream, okay, can we mix them? Okay, let's mix them. And we will prepare. So after mixing, we can have a mixed one chocolate. I mean, we mixed one chocolate and one ice cream to make a chocolate ice cream. Okay, can we can you tell me, tell many chocolate ice cream we can make with one Cadbury and one bowl of ice cream? So it's obviously using only the chocolate. We can prepare this chocolate ice cream. It's okay. So take more examples. Like here I have three chocolate and one ice cream. Okay, so how many ice cream we can prepare? Okay, this is the problem. So how many chocolate ice cream, or maybe the different, like a Kit Kat flavor, five-star flavor, Dairy Milk flavor. So how many ice cream we can prepare? So these are maybe the combination: Dairy Milk with some ice cream, Kit Kat with some ice cream. So these are some kind of combination of chocolate ice cream. Okay, so here I have given another type of ice cream. Okay, maybe the butterscotch. Okay, this is the vanilla and the butterscotch. So the problem is little bit bigger. So you can mix in many ways. Okay, so what are those? So we can have the Cadbury vanilla chocolate ice cream, Kit Kat vanilla chocolate ice cream, five-star vanilla chocolate, and also Cadbury butterscotch, Kit Kat butterscotch, five-star butterscotch. So there are many combination. So do you notice this chocolate ice cream are different from each other? So each and every chocolate ice cream is different in flavor. Okay. Uh, so how many things are like a six combination is possible. Okay, so these are kind of, we will say this is a problem of mix and match. Okay, mix and find out the how many combination is possible. Okay, in my previous section I given some kind of example like a shirt and pant. So they are also in the similar line. This kind of examples I have put here. Okay, so I'm going one by one, a little bit in difficult. It's a bricks example. So like I have the red bricks, green bricks, and blue brick. Okay, so how many tower we can make? How many tower? So these are the tower one, red, green, blue, red, blue, green, green, red, blue. So this way we can prepare the six towers. Okay, so there is no condition now. There is a one condition I have given. We cannot keep blue brick at the bottom since it is the weakest. So I have given the we cannot put the blue brick in the bottom because it's the weakest. It will collapse under the weight of green and red. Okay, so we cannot put the blue brick. So how many then how many this kind of combination, how many walls we can prepare? Okay, so there are six towers. Okay, but this is not possible because blue is here, here also blue is here. So we can only have the four brick tower. Okay, agree? Okay, so this way we need to think. Okay, so okay, Now I am putting the more condition. Now the owner of the tower tells us he doesn't like the combination of red and red bricks together, so we cannot put green and red together. So now we cannot, I cannot put the blue in the bottom, and also we cannot have the red and green bricks together. So what is in mind, how many bricks tower we can make? Okay, so you think that red and green is there, so this is so the combination is red and green should not be together. Okay, so red and green should not be together, red and green should not be together, red and green should not, so only the two combinations are possible, two tower is possible. So we are minimizing the combination. So after if I am giving more and more condition, the number is reducing. Okay, so okay, similarly, now the owners tell us doesn't like the combination red and greens. Okay, now we cannot the blue. Okay, so these are the final combination I have seen. Okay, so more bricks. It's a yellow bricks come to. So we need to. I mean, prepared some tower using red, green, blue and yellow. So we will follow the same thing. So we will write we will think and prepare these 24 towers. Then we start giving you the different condition. So let's say cannot keep red brick on the top. Okay, so there is a one condition, red brick cannot be on the top. So this condition is not possible. So there are only 18 towers is possible. So this way we can think and write, but it's a very difficult. If I increase the number of style of bricks, then it's a very difficult to identify those things. So, okay, so here also another condition. Okay, earlier we had we told we cannot keep red bricks on the top. Now let's say we cannot keep red brick and yellow brick together. Red and yellow cannot be together. Okay, so we will find out the red and yellow. Okay, and we will cross those towers. So there are now 8 towers, is 8 is a possible answer. Okay, so this way we can start thinking, but somewhere we will going to stuck. Okay, uh, this is what we have done so far. We listed on the all of towers, then we crossed off ones we didn't want. Finally we count the remaining. Let's we if we can do this directly in one step, then all the three steps. Remember our constraint. Red brick cannot be at the top and red and yellow brick cannot be together. So we will trying to find out some kind of pattern. Okay, let's analyze this thing, like a red bricks cannot be on the top, so red bricks cannot be on the top. So it can start with green, blue and yellow. Okay, that means green, yellow and blue bricks on the top, but we cannot know what the other bricks will be. Okay, uh, so go to the next. Let analyze this line, red and yellow brick cannot be together. Okay, so red and yellow brick, so these are the possible combination, but red and yellow brick cannot be together. This means we can have yellow green, yellow blue, yellow red blue, red green, green blue bricks together. Let's see how this will look. So these are the probable combinations. Only we cannot take the red and yellow together. So we can again start thinking like we will add with the yellow thing, let's we add the yellow brick after the green brick. Okay, so this way we will try to finalize. Okay, so one by one, and then we complete this is a one tower. like uh, what is this is started with the green, so after that blue, yellow, blue and red is possible. So these are the different combinations. So if this way we can think, then we can and probably complete the all the possible towers. Okay, so what I have in the recap I will say that we have listed, and we have draw the different towers, and we then listed all the combination possible with these bricks. We are also carefully not to repeat any tower. We not we will not repeat the any tower combination. Okay, so these are the probable combinations, with the three brick, with the 3 bricks we have the 6 towers. With the 4 bricks we can have the 24 towers. So these are the maximum possible combinations if we can draw this way. Okay, need to figure out the how many tower is possible. Okay, so then the concept is coming, the counting with multiplication. So there is some kind of patterns are there. So did you notice that in the last page, when we increase the number of bricks from 3 to 4, the number of towers increase from 6 to 24. So when we use the 3 bricks, then we can build the 6 towers. If we use the 4 bricks, then the number is 24. Okay, so we will see in so what is the condition? Can you tell me how many different bricks tower can be make if we have the 5 different colors? Like I'm getting another, this is another question, like red, green, blue, yellow and black. If I have these 5 colors, how many possible combination is can anybody try? So if I have the 5 different color of bricks, how many combination of bricks is possible using the same method? Obviously we can use the same method earlier for the listing of towers and then counting. That's obviously one procedure, but can you think in different way? So if I have the 5 different colors of brick, how many maximum, without any condition, how many maximum bricks tower is possible? So then the thinking is coming about the multiplication, counting with multiplication. There has a different way or easier to solve this problem. Okay, so what is that? So let's try a new way of counting. Let's say we have the first 3 bricks of different color. Now we get the total number of multiply, like a 1 2 1 cross 2 cross 3, so it's a 6. So for the 4 different bricks, 1 cross 2 cross 3 plus cross 4, so it's a 24. So 24 total number of tower can possible. Similarly for the 5, what will be the answer? Can anybody try? It's a simple same process. 1 cross 2 cross 3 cross 4 cross 5 is a 120. So 120 possible towers we can build using 5 different bricks. So it's a little bit yeah, too easier to understand or easier to we can multiply the number and we can find out the how many different towers is possible without any condition. Okay, so is it clear up to this counting with the multiplication procedure?
Yes, sir.
Okay. Uh, so only thing is that if we can, given some kind of conditions, then we can also find out or subtract that conditional value. Okay. Here I am giving that if I have the 5 different colors, then how many possible combination of tower is possible. Okay. So that is 120 possible combination only using the multiplication that we can do. So those who are from the mathematics background, or those who are in the class 10 also, we learned about the factorial thing. I think some of you can remember the factorial 5 also is equal to 5 in cross 4 cross 3 cross 2 and cross 1. Okay, so this is like a factorial thing, but it's a very difficult for the children with in class 1 or 2, or maybe in class 4 also is very difficult to understand this concept. But using this kind of multiplication thing, because the multiplication they know very well the multiplication. So if you can give your idea and give this kind of counting system using multiplication, so they can play with such such kind of bricks problem. So that's the main agenda, or that's I need to convey to you. So that's the beauty of the counting and listing part of the this topic. Okay, so there is another problem. So here is a sham is has go to Pune. P for Pune, V for Vasi and M for Mumbai. So someone is going for Pune to Mumbai via Vasi. Okay, so there are possible I mean possible roads are there. So this black color is possible one condition. So if I mean Pune to, you can take this road, and you can also take this road to reach Mumbai. Similarly, you can take also this road, I mean lower road, and you can take also this lower road to reach Mumbai. So then how many combinations is possible to reach Pune to Mumbai via Vasi? That's the problem. Okay. So we will start counting again, like a p, we can use this path, and this is path, this path. So this is path 1, and this is path 2, this may be the path 3. So this way we can write one by one and draw. Okay. So after this I mean this step by step process and the drawing, we can achieve, there are we will say there are possibly 9, because in step 1 the number of roads from Pune to Vasi is 3, number of Vasi to Mumbai is 3, then the total number is 3 cross 3. This is the beauty of multiplication. Here we can directly reach to the I mean total number. So if we count my previous slides, how many paths is possible, so 9 is the answer. And if you use the multiplication method, the multiplication, you will see that from Pune to Vasi there are 3 possible condition, I mean 3 possible road. Similarly, in Vasi to Mumbai there is also 3 possible road. So that's why we can say the 3 cross 3, 3 multiplication by 3, there is a total 9. So 9 possible combinations are valid combinations are there from to reach Pune to Mumbai via Vasi. Okay. So that is the I mean beauty of the multiplication in the counting. Okay. So obviously we can draw one by one, and we can find out and we can count that how many way we can reach this Pune to Mumbai via Vasi. But the power of multiplication is like that, the total possible routes in Vasi, Pune to Vasi is 3, and Vasi to Mumbai is 3. So we can use the 3 cross 3 is equal to 9. Okay. So understand this, is it clear to all of you? Okay. uh, there are many more paths between Pune to Vasi. There are 1 2 3 4 5, 5 path here, and Vasi to Mumbai there is a 3 paths. Can anybody tell me the how many possible combinations are there from to reach Pune to Mumbai via Vasi? Anybody?
50,
Right.
15.
Right, because Pune to Vasi is 5, and Vasi to Mumbai is 3. So 5 cross 3 is equal to 15. So possible combination is 15. But you can also, I mean for like a class 1 or class 2 student, you can also draw like a some combination, and you can demonstrate them. These are the possible 15 combination, but maybe in the higher side, or maybe after learning the I mean multiplication kind of thing, this kind of puzzles or this kind of game can be helpful to the children also to learn multiplication using counting. Okay. So this is more. I have added another destination, Goa. Okay, so there is a Pune, Vasi, Mumbai, and Goa. So there are 1, 2, 3, 4, 5 path. Then Vasi to Mumbai, 1, 2, 3, 4 paths, and Mumbai to Goa there are 4. Sorry, there is two roads. Then how many? I mean possible combination for to visit Pune to Goa via Vasi and Mumbai.
I
Same logic, yeah, same logic. You can try like a 5 cross 4 cross 2. Okay, there are 40 possible combination. So so is it clear?
Yes, sir.
Okay. Okay, fine. So so it's a I mean very interesting I mean this I will say the path related problem is very interesting. So if we can I mean visit one by one and demonstrate to the children, and they can easily can understand, they can find out the how many steps are there. So they can also find out the how many steps, so what are the I mean possible combinations, and they can also learn how to count the possible paths. And after maybe in the higher class, you can after teaching the multiplication, you can say that this is the operator, multiplication is there, so you can use this operator to find out the number of paths. So important is the thinking is very important. In my lecture, in my two session, I never say anything about to write any programming language. But those who are from the computer science background or little bit familiar with the like a different programming language, they can say it can be easily it's a very easy problem for the computer, but it's not so much, it's not easy to the human, because human need to understand the step by step problem, and need to find out the pattern, and then abstraction, then need to write out the logic algorithm. So after you finalize the algorithm, then only computer, then only computer science students can write some code. Okay, but the before writing the code, thinking process is the same for all. So without knowing any computer knowledge, or maybe the computer programming knowledge, you can also logically find out the solution step by step for any problem. Okay, so to only you need to find out, there should be some kind of break down the major, big problem in a smaller problem. Then we need to find out some different steps, and some kind of patterns are there within that, different steps. Okay, so we need to find out some kind of patterns, and then superimpose some kind of abstractions. If I can use this multiplication or addition kind of thing, is it solve my problem? So you need to think in that way. So you need to write a kind of you need try to formulate one kind of equation. Okay, so equation is very important. You need to think. It's may or may not be possible to write the equation for the all application, but the thinking is the same process. Okay, so now I will start with some Sudoku problem. It's a 1 to 9. It's a bigger rows, 9 rows and 9 columns are there. Okay, so it's a 3 by 3 subgrid, so it's a big problem. Why I'm taking this Sudoku, because all of you are very much familiar with to solve this logic problem. Because if you solve this Sudoku problem every day, so it will increase your computational thinking. So each and every time you need to think what are the possible steps, or maybe the next steps should be there. So you need to memorize so many things. You need to you need to count so many things. So Sudoku is one of the game and one of the puzzle. It can be start with the smaller smaller mini grid, but it can be 1 cross 9. It's a 3 by 3 subgrids are there. So obviously there are some steps we need to follow. So this is my today's problem, like a 9 cross 9. Okay, so if I can give you this problem and to all of you, and give some time, obviously I know that some of you maybe can all of you can solve this Sudoku problem very easily. Okay, so in but you know that for the solving this Sudoku problem, this is also kind of logical thinking is required. Because each and every time this some rows and columns are there. Okay, so these are the rows, this is a section 1, this is section 2. This is 3 cross 3 subgrid, this is 3 cross 3 subgrid. There are 9 subgrids are there. There are different rows and columns are there. So we can solve one section by another section. Okay, so obviously there are different solving technique. Relatively easy Sudoku puzzle can be solved by a sequence of elimination of all impossible things we can eliminate. However, the difficult ones, there are some difficult Sudokus are also there. So that logic, some difficult logic is also involved. Okay, but some basic techniques to solve the essential part is the same for the advanced, or maybe the the easy one also. So in this slides I will show you some kind of steps. But I will say this is the thinking, one thinking process. I am thinking in that way, you may think in different way. That's not it is not that you are thinking wrong. It's you are thinking in a not correct manner. You are also thinking in a correct manner, but here I am trying to show you some technique. Most of the Sudoku players, they follow this kind of technique. Okay, so the basic techniques are hidden single. So we will try to find out the most common and basic technique. This is the most common and basic technique to start with the solving Sudoku puzzle. So when trying to determine where the digit should be placed in the row or column in 3 by 3 cross 3 box, we may find out there is only one cell in this digit can go, and therefore it has to be that cell. I mean, we need to find out a single cell. Okay, like I give some example. Okay, so this is the example. We need to find out what will be this I mean this question mark with some digit 0 1 to 9. So if you see this 8 is here, okay, in this line, so 8 is not possible to write here, okay, in this. So 8 is also here, so 8 is also not possible to be here. So only this section we can write 8. So this is the only possible way to write the digit 8. So this is we call is the hidden single. There is a no confusion. Sometimes we will also show you sometimes we are facing some difficulties that it may be three of these two or three places, or it may be seven, but this in this condition it should be eight in this place. Okay, uh, for this yellow. So so that is one technique. So we need to find out from the entire Sudoku problem. First of all, we need to find out the similar kind of activity, that how we can put the without any confusion, how we can put any digit without any confusion. So this is the hidden single concept, we will say. Okay, so is it okay to all of you?
Yes, sir. Yes.
Okay, so actually I'm trying to
Yes, sir.
give you some example to how we can. There are obviously there are many steps are there, but these are the very basic techniques, we will say. So we need to find out this. We need to find out this location where we can put 8. Okay. Okay. Next is the next technique is the sole candidate. This is another very basic technique for solving Sudoku puzzle. While considering what digit from 1 to 9 are possibly placed in any empty cell, one could first find out what digit have appeared in the common row column by the 3 cross 3 box with the cell. Okay, just go to the example. Okay, so this is my problem. We need to find out the what is, just don't see about the left section, just try to concentrate on this puzzle. Can anybody try to say that what will be the possible digit of this YOLO section? So can you please try? So let's see.
Sir, there
Yeah,
is a
please. Yeah, please.
three, three.
Yes, 3 is the correct answer. Why 3? So if you can see, like a 1 2 is here, okay, and 4 5 is here, so it should not be 4 and 5, or maybe the any digit can be 4 or 5 is not possible. Similarly 6 or 7 here, so 6 7 is also not possible. So only the digit 3 is possible to in the middle. Okay, why in the middle? Why we can't write here 3? Because we don't know, maybe here is this this cell is only for the single digit on for the 3. So you can so we need to find out this cell. So these are the very basic techniques. There are other technique also. So locked candidate. Okay, so locked means, so like a 1 2 5 6 are there. Okay, and this is 3 is written. So this section we can't this is 3 is not possible to write here. Okay, so maybe the probable answer 3 can be right here or here. So we can write that the possible this EULA location we can write 3 or these two places. Okay, so this is kind of we will say that locking, we are locking this cell with the 3. Similarly this technique is removing candidates. Okay, so if 7 is here, so 7 and a 7 is not here. Okay, so okay, please read note that this method will not help you to find any new numbers, but this will help you to find the number down with the specific row and column. The example shows that the number 7 can only be inserted in the yellow. So it can be yellow here and yellow here. Okay. And so if I can write 7 here or 7 right here, then we cannot write 7 here. So in this cell, we can omit, or we can remove the 7. Is not possible in this red location. So hence we can remove the 7 as the possible candidate from the rest of the row which are red in color. So if 7 is here, so we cannot put 7 in this location, but we can put 7 here, either 7 here or here. Okay. But if we can write 7 here, we cannot write 7 digits in this location. So we call this the removing the candidate. So these are the very basic basic problems, I mean basic steps. If you can remember these steps, so it will be very easy, or you can easily solve the Sudoku problem. So okay, there is another technique we will call it the block or block iteration. Okay. So this technique is the best understood by looking at the example in this middle, uh, in this middle, in the middle and the middle right block, the number 8 must be placed. The number 8 is placed here, so it cannot possible to 8 here in this location, and here in this location. Okay. So this means we can eliminate 8 from the upper and lower rows in the middle right column of this red. So 8 is not possible to in this location. Okay. So we can write 8 here, 8 here, it's not a problem. So we cannot write here in 8 in other places. So in their advanced techniques, we will say there are other advanced techniques when you have more than one right candidate for one cell. You can consider the subset of right candidate to be filled and proceed. So we can block the, I mean block the cell and we will proceed. So in this way, if we keep in keep these basic steps in mind, and if we can proceed, then you can think that the time duration to solve the Sudoku may be reduced. Okay. So there are some steps. So these are some Sudoku challenge for you. So if you can try, so you can try. So I will not go step by step again details. So, so Sudoku, I will say the Sudoku is a very interesting problem. So, in my case, I love to play Sudoku and try to solve smaller one, basic one, and sometimes in advanced one. And also I try to, keep the clock on so that I can reduce the by I mean my computation time. Okay. So how much time I am taking to solve one basic Sudoku or maybe the advanced Sudoku? Obviously, for the advanced Sudoku, we need some more time rather than the basic Sudoku. So it's a very interesting challenge, interesting problem. So I request all of you, all the teachers, you can also try the Sudoku problem, and try to focus on some basic rules, trying to remember some basic rules. Okay. Oh, again, it's another interesting, and but it's a very easy. So I just there's a five problem, 1, 2, 3, 4, 5. I request all of you just try to find out what is the possible answer. Okay. So I request all of you to. It's a very easy. I mean, if you can think, then you can easily solve this problem. It's a picture analogy. So most of the teacher, uh, it's a very interesting problem, but very easy. Can anyone help me? So problem number one, A, B, C. Which one?
Yes. I think that is C.
Okay, great. Anyone for the two?
For 2, that is B.
Okay, B. Three. Number three.
Again B.
This one.
Yes, sir. Yes.
Okay.
No, no, no. No,
Mm-hmm.
not A. A.
A.
Yes, sir.
Okay. Okay. Number four.
4 for C.
Uh, C.
Yes.
Okay. Number five.
Number 5, B.
Okay, let's see. So is this your correct? I
Yes,
think
sir.
all of the correct. Yeah,
Yes.
great, great. So why? Because it's a very, I mean, you need to think, the shape, and find out the possible, possible output. Okay, so okay, I have another one. So which number replaces the question mark? So we need to find out this number. So I request all of you try or take some time.
Sir,
From,
I,
pardon, please.
sir, can I give the answer?
Yeah, please.
Yes, option one, 6.
Okay, anyone else? Any other? uh, can you please elaborate how we can reach 6? Why 6? Option 1.
Sir, because when I observe that that is the difference between the two numbers of below, like 7, 9, the between number 8 is above.
Okay,
So similarly, we can find the 5, 7, then
right,
6 is, then we
right,
write 8.
right. So after thinking, you try to find out and some pattern. So this is a 3 5, so between number is 4. 5 7 between number is 6. 7 9 between number is 8. Similarly 5 7 between number is 6. So 6 is the correct answer. Good. So this is another problem. Can anybody try? uh, take your time, no problem.
Sir, there is an option. I think there is 54.
There is no option, but you can try. uh,
Sir, 54.
54, how? Try. I mean, give me the reason.
Sir, in first, there is a 9, 9, and 3. We can add 9 plus 9 plus 3, that is 21.
9 plus 9.
In first images,
It's a
there is a
9 plus 9 plus 9 plus 9 plus 3. 21.
yes.
Yes, correct.
It,
It's a 21. It's a, I mean, it's a showing. It's a 21. This is 1 plus 1, 2, 3, 4. This is 10 plus 10 plus 10. 10 plus 10 plus 10, 30. This is
yes.
5 dots are here. So 5 plus 5 minus 5. So 10 minus 5 is equal to 5. So
Uh,
then,
I think 285, sir.
pardon, please.
285.
285. Okay. Anybody else? 285.
85, sir.
Haha. Pardon?
85.
85. Okay. Another. So for 285, how we can reach this number 285? Can you please explain a little bit?
Yes,
Of
first 9, then
9.
add 10, 19, and multiply by.
This is not 10. This is for 1, 2, 2, 4. This is 9.
Okay,
Okay. Okay. So you can
then
recalculate. Okay. Again.
okay, then 18 into 15.
This is again 4 dot. 1 2 3 4. 4 dots. There is a 1 2 3 4 5 dots, and it's a very clever, I mean, clever problem. Like he's put 1 2 3 4 dots.
39, sir. 39.
39. So how you reach 39? Can you please explain?
Okay. Just 1 second. Let me calculate again,
Yeah,
sir.
please, please.
Sorry.
Yeah, please calculate.
Sir, 2016.
2016. How? Can you please explain? So this is 9.
57, sir.
57. How you reach 57?
So 9 plus 10.
No, that is
19.
not 10. That is not 10. This is 9 also. 1, 2, 2, 4.
Okay,
1, 2,
sorry, sir.
4.
1, 2, 3, 4. I just
Now
miscalculated
1,
that.
2, 2, 4.
2,
1,
4. Okay,
uh,
10
this is
and
9.
19.
This is 9 again. 4 plus
9,
2, 6, 6,
18,
8, 8
and
plus
18
1, 9.
into 3, sir.
Why 3? Why 3?
Oh, sorry, sir. 5. 18 into
Two,
5. 90, sir.
216, sir.
216. Okay, no. 216 is also not correct.
So 270.
And 17.
How? 271 answer. Another answer is
270. 70.
270. Another, someone is telling some other answer.
117.
107. Okay. 270. Can you please explain how we reach?
What is 7? 7 plus 9.
Where is 7?
This watch.
This was is 9.
So 3 was 9. 7 7 3 7.
Because this is the 9. This is 9 o'clock plus 9 o'clock plus 3 o'clock. So 9
Okay,
plus
okay,
9 plus 3 is equal to 21.
okay. Mm,
Similarly, this is
1.
also 9. 9 o'clock.
Yeah, 9 plus 9. 18. 18 into 15.
This is also 4
5.
dots are there, not 5. This is the 5
Okay.
dots. 5 plus 5 plus 5 plus 5, 10. 10 minus 5, 5. But this is 1, 2, 3, 4. This is 1, 2, 3, 4. This is also 1, 2, 3, 4. So total, how much?
12.
Yeah, 12. Correct.
Okay.
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 Now we think.
9.
Now you think.
Okay. Okay. Okay.
Someone is saying 2016. I mean, this is also not correct. Just recheck your answer.
So it will be 216.
216. How? Can you please?
9 plus 9, 18. 18 into 12.
Okay. Okay. So your answer is 216. Okay. Someone is saying 114, 117. Who?
Yes, sir.
How you can reach 117?
Sir, we just multiply 9 into 12, that is 108, and then we add 9, that is 117.
Okay. Actually, I will say that 216 and 117 both are very close to the answer. I mean, and one answer is correct, one answer is not correct. Because you see that I will just give one, try to give some kind of. So this is 9. That's not a problem. So 9 plus, this is also 9. 4, 2, 2, 1, 6, 8, 9. This is also 9. This is also correct. And this is 12.
285.
285. How? I mean, what's your, I mean, how we can reach 285? Can you please, I mean,
949 and calculate
9, 9?
9 plus 9 18. 18
Okay.
multiply by 15.
Oh, that is not 15. Sorry, sir. This is actually 12. 1, 2, 3, 4.
117, sir.
1, 2, 3, 4.
117, sir.
117 is a yes. 117 is another answer. One answer is 216. So both are the, I mean, 9 plus 9 into 12. Okay. Uh, but you see that, I mean, if we have this plus, I mean, addition and multiplication, then we will give the, I mean, weightage on the multiplication first. So 9
Yes,
plus,
after
within
the
bracket,
podcast,
9 plus 12. So 9 plus 12 is 108. 108 plus 9 is 117. So correct answer is 117. Okay. So, I mean, first of all, we need to find out the numbers 9 plus 9 cross 12. But the as per the mathematics, we need to, I mean, give some weightage on the multiplication. So we will do multiplication first, then we will add. Okay, so that's why it's a very tricky. So 216 also, it's a very, I mean, going to the correct, yeah, path, but he or she is calculated 9 plus 9 18, 18 cross 12. That's only the problem. So the correct answer is 9 plus 9 cross 12. We will give some weightage on the multiplication first. After multiplication, we will add. Okay, so that's why the correct answer is 117. So I think all of you are give some will try, and I'm very happy that uh, all of you are thinking to solve this kind of reasoning problem, because this is also the part of the this completion thinking. This thinking, it's for this completion thinking, you need not to run or need not to write any computer program. Only you need to think, or need to find out, and need to find out the patterns, and you need to decompose, you need to find out some patterns, and some abstractions are there, and finally some algorithms. Okay, so these are the four main steps for the completion thinking for the all, I mean all subjects of completion thinking. So correct answer is 114. I don't have much slide, so I will say that is in the within the completion thinking, like a decomposition, pattern recognition, abstraction, and algorithmic thinking, these four is very very important. And for the completion thinking, it's you need to uh, do some kind of I mean I will say need some training. Like a training means, like I'm trying to give you some kind of examples. So these example is very important to brush up your thinking process. So I am not saying anything new to you. I am not give any examples that is not known to you. Everything is known to you, only you need to think yourself. Okay, and need to think in such a way so that you can decompose the problem, bigger problem, in a small problem. Okay, then you need to find out some kind of patterns within that, and then from that you need to find some kind of algorithm, or some kind of addition, subtraction, some logic we need to impose on the thinking process, and need to come up with the final output. So it's I will say it's a for this kind of competition thinking process, you need to uh, uh, train yourself, so that you can also go back to teach your students. And this kind of competition thinking, this kind of subject is currently introduced in the in the course curriculum also. Like I'm saying that like IIT Bombay is also, there is a one team, one department, they are working only on the competition thinking. Okay, so and each and every time we are thinking about the from the class 1 to class 8. Already America, United States and the United Kingdom, so they are already much more ahead of us. Okay, they have already this kind of activities already they are in their curriculum. Okay, but in India we are a little bit behind, but we are in the same path. We are not far behind, we are behind obviously, but we are in a transition to learn this computation thinking, to introduce to our new education policy 2020, so that we can also train our students, and try to give some kind of input so that they can start thinking from the initial life. Okay, so I will just before to complete, these are the some references from where I have taken some kind of inputs for the preparation of slides. Okay, um, and examples. So thank you from my side. But before going, complete my session, I have some another website I would like to show you. This is a very interesting website. This is the website of CS Pathshala, and from this website, I think some of you or maybe all of you are already visited this website. I like to play one video for all of you. So for the completion thinking part, uh, so just give me some time. You can also visit this website. Just listen.
How do you map the entire human DNA sequence? Is it really possible that William Shakespeare wrote all of the works that bear his name? Can you create an intelligent computer program that can write its own novel music compositions? What do these three real-life questions have in common? Well, answering these questions requires the use of computational thinking, which is a way of thinking that more and more people are using to solve problems each day. So whether you teach math, science, computing, or the humanities, computational thinking can be a powerful addition to your classroom activities. So what is computational thinking?
Computational thinking is an approach to problem solving. So it's taking apart a problem and figuring out how to attack it using what we know about computation. There's four major sort of facets of computational thinking. One is decomposition, breaking something down and figuring out what all the parts are and how you might divide up a task.
And then there's pattern recognition, which is finding similarities and differences between these parts in order to make predictions. Pattern generalization, or abstraction, which is finding the general principles that generate these patterns. And finally, there's algorithm design, which is developing the step-by-step instructions that solve similar problems. People are learning to apply computational thinking to solve problems in many disciplines. When people ask difficult questions, which are more easily solved by computers, or discover insights through analysis of large data sets, they are thinking computationally. Computational thinking is the reason we now have fields like computational biology, computational chemistry. It's also the reason we have new techniques we can use in literature, social studies, and the arts.
So when we start stepping back and looking around us, we see computational thinking everywhere, and it doesn't have to be a scary thing.
Some people confuse computational thinking and computer science, but they're quite distinct. Computer science is an academic discipline involving the study of computation and its application using computers.
Whereas computational thinking is a way we go about attacking problems.
Right, using big picture processes and abstract ways of thinking.
It's something that you could use regardless of whether or not you're a computer scientist or something else. It's a general skill that would benefit you.
Computational thinking increases students' confidence in dealing with ambiguous, complex, or open-ended problems. We believe that all students should learn computational thinking, regardless of subject or age group.
Being able to take a problem, break it down into many different sized pieces, work on each one individually, and eventually bring it all together to solve something, that's a skill that can benefit anyone.
Imagine that you're a journalist and that you want to know what people are saying about an upcoming election. One option is to ask people on the streets about their opinion. Another option is to use a computer program that can analyze social media posts on thousands of web pages in just a few seconds. See, this is an example of the benefit of approaching a problem computationally. So, in the past, if students wanted to see and understand data, they needed to collect the data manually. Now, by developing an algorithm, students benefit from quick results and are able to focus their attention on insights rather than data collection or calculation. By leveraging the strengths of technology, we can focus on our strengths as people, developing insights, analyzing situations, and drawing conclusions. We don't want students to simply use the models that we teach. We want students to be able to create their own models. And to do so, students must find the hidden patterns and insights that can be discovered with computational thinking. Computational thinking is not an additional burden or an extra topic that needs to be taught. Rather, it's an enhancement to your existing curriculum.
So with my students, early on, I just try to use everyday examples to help them understand that it's something that's accessible to them. And then they can start to see how computational thinking does exist in other aspects of their life.
If our students are technology creators, armed with computational skills, they will not only be able to participate and position themselves professionally in a global society, they'll also be able to contribute to society by solving big problems using creativity. So how did we map the human genome? Well, algorithms and computer programs helped us to sequence the millions of base pairs in our DNA. And what about Shakespeare? Turns out computational analyses of the vocabulary, themes, and styles in Shakespeare's works confirmed that he could have indeed written all of the works attributed to him. And that intelligent music composing computer program? Well, computational thinking was used to find patterns in existing musical compositions and write programs that produced brand new compositions based on those patterns. All of the remaining grand global challenges facing us as humans are problems that require an interdisciplinary approach. By integrating computational thinking skills in all of our subjects, we're preparing students to contribute new solutions to seemingly impossible problems. So yes, many mysteries still remain. For example, what causes gravity? Can we create cures for diseases like cancer? We may not be able to answer these questions today, but perhaps with computational thinking skills, our students will be able to answer these questions in the future.
So I'm just stopping sharing my screen. So it's a very interesting topic, very interesting topic of computational thinking. It's mentioned that it's a interdisciplinary approach. So I request all of you just think and step by step manner, okay, and think to solve some kind of reasoning and start counting with some multiplication, and try to solve puzzles, like a small puzzle, to not only for yourself but also for your students, so that you can give them some this kind of puzzles, so that it will help. Okay, so that's my submission to all of you. So if you have any suggestion, any feedback from your side, it will be very much helpful for all. Okay, thank you for your patience of listening. Thank you.